Ever wondered why things fall down? Like, why does that juicy apple hanging from the tree always end up splat on the ground and never mysteriously soar into the sky? It might seem obvious, but that seemingly simple question has puzzled humans for millennia. In fact, it wasn't until a curious and brilliant dude named Isaac Newton came along that we finally cracked the code. But Isaac Newton wasn't just some guy who liked apples, though maybe he did. He was a scientific rock star who revolutionized our understanding of the universe in a way that still shapes our world today. So, buckle up because we're about to dive into the mind-blowing discoveries of Sir Isaac Newton. Now, you might already know Newton for the famous story of the apple falling on his head. While the truth is a bit more nuanced, no documented head injuries here, the story does highlight the spark that ignited Newton's genius. He started questioning why the apple always fell down, not up or sideways. This seemingly simple question led him down a path that would change physics forever. Newton realized that the force pulling the apple to the ground wasn't just some earthly quirk. He theorized that there was a universal force at play, one that not only affected falling apples but also governed the movement of the moon around the Earth and the planets around the Sun. This unseen force he called gravity. Here's the cool part. Newton didn't just propose the existence of gravity, he actually laid out the mathematical foundation for understanding it. He published his groundbreaking work in a book titled Philosophiae Naturalis Principia Mathematica, often shortened to just Principia. This masterpiece explained his theory of universal gravitation, which essentially states that every object in the universe attracts every other object with a force proportional to their masses and inversely proportional to the square of the distance between them. Yeah, that's a mouthful. But what it means is that the bigger and closer two objects are, the stronger the gravitational pull between them. This one principle could explain why apples fall, why the moon orbits Earth, and even why planets travel in elliptical paths around the sun. But wait, there's more. Newton wasn't a one-trick pony. His insatiable curiosity led him to explore other realms of science as well. He made significant contributions to the field of optics. Remember how when sunlight shines through a prism, it creates a rainbow? Well, Newton discovered that white light is actually made up of a spectrum of colors, each with a slightly different bend. This groundbreaking work helped lay the foundation for modern optics and our understanding of light. And then there's calculus. Yes, that very subject that strikes fear in the hearts of many students. Believe it or not, the development of calculus is also largely credited to Isaac Newton, though Gottfried Wilhelm Leibniz also deserves some recognition. Calculus is a powerful mathematical tool used to analyze changing quantities and motion. It was essential for Newton to fully develop his theories of motion and gravity. Speaking of motion, Newton also formulated his 3 laws of motion, which are still the cornerstone of classical mechanics. The first law states that an object at rest stays at rest and an object in motion stays in motion with the same speed and in the same straight line unless acted upon by an unbalanced force. The second law explains how force equals mass times acceleration. And the third law tells us that for every action, there is an equal and opposite reaction. These seemingly simple laws have profound implications. They explain how objects move, how forces interact, and have become the foundation for countless inventions and advancements in engineering, space exploration, and even our understanding of sports. So, the next time you see an apple fall or watch the moon gracefully orbit Earth, remember the genius of Isaac Newton. His insatiable curiosity and groundbreaking discoveries not only changed the course of science but continue to shape our world in profound ways even today. With that said, thanks for watching and until next time.